This is Unit 6, Lesson 6, Slope-Intercept Equations, Day 1. I want you to recall what we did back in Unit 3 when we had word problems and we used algebra equations to solve them. Let's look at this problem. Daniel has $58 in his piggy bank. He gets a job mowing lawns, and he charges $15 per lawn. If Daniel has $223 in his bank, how many lawns did he mow? So we first started out using a word equation to help us figure out how to turn that situation into an algebra equation, and we had some labels that we used, and you can see that one of those labels is the variable x, because that's the piece of information that we don't know yet, and then we turned that into an equation. And we were able to solve that equation because we had just one missing piece of information, x. We solved for x and got 11, and so knew that if he had $223 in his bank, he would have mowed 11 lawns. Let's take a look at example 1, part B. We've got the same situation, sort of. We've got Daniel with the 58 in his piggy bank, and he gets a job mowing lawns, charging $15 per lawn, but then we don't know any additional information. So at this point, we'd like to write a linear equation that models that situation. So we don't have all the same information. We still would use the same setup for our equation. And if you look at our labels, you can see we've got the same starting amount in the bank and the mowing charge of $15. We don't know how many lawns he mowed, so we can still call that x, but now we don't know how much is in the bank. That is not specified, so we need a different variable to represent the amount in the bank, so we're going to call that y. Now when we go ahead and plug in all those pieces of information, we've got the same start, but then instead of having an amount in the bank, we're going to use the variable y. So now we've got an equation that has two variables in it, an x and a y, and when that's the case, it's called a linear equation. We'll find out why in another couple of lessons. But often when we have a linear equation, we write it with the y on the left, so we would write y equals 58 plus 15x. So that's an equation that models this situation. Be sure that you're writing this down on your note sheet. All right, example 1, part C, we're going to start with that information that we have already. Our x and our y are variables standing for some information, and there's our equation. So can we solve this equation? What does that really mean? Well, solving it would mean finding an ordered pair that makes the equation a true statement. We did this before where we were given an equation with an x and a y in it, and we could find some sets of x and y variables taken together in an ordered pair that when we plugged in the x and the y, it would make it a true statement. That's what the solution is. So here's my question. Is there one solution? How many solutions are there? Is there one, more than one? In fact, there are an infinite number of solutions. When there's an x and a y in the equation, it means we can come up with an infinite number of different x, y ordered pairs that would satisfy that and make it a true statement. So let's find some of those. Let's determine some of the solutions to this equation. So let's start out with an x value. What if he mowed one lawn? Well, the number of lawns mowed is being represented by our x. So if he mowed one lawn, we would put the value of 1 in for x, and then continue to simplify and solve to get the y value that goes with it is 73. We did that before when we were graphing equations. So it's the same thing here. But now those x and y values have a meaning. So if he mowed one lawn, then he would have $73. And we can represent that in an ordered pair. 1 for x, 73 for y. So the solution, one of the solutions to this equation would be the ordered pair 1, 73. Let's try it again. What if he mowed 7 lawns? This time we would replace the x value, because that's the number of lawns mowed, with a 7. So we're going to replace it with a 7, simplify by multiplying and then adding, and get y equals 163. So if he mowed 7 lawns, then he had $163 in his bank. That's the ordered pair 7, 163. What if he mowed 10 lawns? We're going to do the same process. Mowing 10 lawns is an X value of 10. So we plug in 10, simplify to solve for Y. We get 208, and he had $208 in his bank. So that would be a solution of 10, 208. All right, example 2. Nika goes to Hal's Hot Yoga, and they charge a monthly fee of $48 plus $3 per class. So we'd like to write a linear equation that models Nika's monthly cost. So we have to figure out what pieces of information are missing. Well, we want to know her monthly cost, but that depends on how many classes she takes. So I'm going to think about this first as an expression, and I know that the number of classes she takes is something that's unknown, so we're going to use a variable to describe it, and that's X. Therefore, the monthly cost is going to be our other variable, and that's going to be a Y. So her total monthly charge will be the variable Y. When we go and put that into an equation, I'm going to first think about the expression piece of it. How do we figure out how much she is going to have to pay? Well, we know that it's a $48 charge plus $3 per class. So that's the expression 48 plus 3x. And so we know when we do that computation, it's going to come out to be her total monthly charge, which is Y. So that's how I'm able to come up with the equation, and then I'm going to rewrite it the other direction. Y equals 48 plus 3x. All right, part 2. 2 questions here. What would be her monthly charge if she took 14 classes? And then, how many classes did she take if her cost was $111? I'd like you to answer these 2 questions on your own. So use your equation, plug in those values in the appropriate spot, and then simplify to solve for the other variable and determine the answer to those questions. So pause the video and then come back when you're ready. All right, what would be her monthly charge if she took 14 classes? We're going to plug in 14 for X because the number of classes is the X variable, and then solve for Y. We'd find out Y is 90, so that means her monthly charge would be $90 if she took 14 classes. We're going to answer that in a sentence. And if we were to answer it as an ordered pair, the solution to that equation would be 1490, one of the solutions. Right, how many classes did she take if her cost was 111? Here, 111 refers to the Y value, the total monthly charge. So we're going to plug that in place of Y and solve to find X. And we've determined that X is 21. That means she would have taken 21 classes if her monthly charge was 111. And we can write that in an ordered pair. That's another solution to this equation, 21, 111. That's it. Put your note sheet in your binder so that you have it for class tomorrow. See you then.